Okay, I think it's time. This is 11:45, so I know people are starting to think about lunch, so I've tried to not make too long a presentation. But I'd like this to be interactive, so I didn't make a ton of slides, so feel free to raise your hand and comment. This is a bit of an open-ended discussion. I'd like to hear thoughts. So my name is Anees Shaikh. Thanks all for coming. I work at Google in the technical infrastructure team in network architecture. We have been, as you know, at Google, I've only been at Google 6 months, by the way, so I'm still in learning mode, but as many of you know, Google has been spending a lot of time looking at SDN and deployments, and we've described in some detail our deployment of SDN in a wide area, and I'm sure you've seen also the presentation that Amin Badad gave at the last Open Networking Summit about how we're using SDN also in our cloud networking solutions for the Google Cloud Platform. But today I'd like to talk about something a little bit different. I mean, there was a great question during the OpenDaylight panel about, well, what is OpenDaylight as a project doing about management and integration with operational support systems, things that service providers or network operators really care about. And I think, as you'll see, the answer is we haven't really done that much yet, and there's a lot more that can be done. So what I'm going to talk today about is how we can get beyond the current focus of SDN. So, I'm going to talk a little bit about where I think SDN is today, what the focus areas have been, where we've been successful as an industry and a community in bringing SDN along. And then I'll talk a little bit about the state of the management plane. So SDN has been focused a lot on control plane. We should revisit and think a little bit about the management plane, and then how we can extend SDN better to management. And then we've started some work recently on trying to build some, first of all, consensus around solving some of the problems in the management plane, using an SDN approach, and then trying to also engage the broader community and industry around helping us get there. Because I think the problems actually apply to many large network operators and users. So first of all, let's see what we've done in SDN. So in the control plane, as far as SDN is concerned, I think there's been a lot of progress. I mean, SDN has introduced and really solidified a bunch of concepts. One of those, for example, is this notion of global visibility, right? So by centralizing the control plane of the network logically, it doesn't have to be physically central in one server, but logically, it gives us this opportunity now to basically get visibility over the entire network and really optimize, how paths are deployed, how traffic is actually handled, as opposed to relying on the completely distributed set of protocols, control plane protocols that exchange information on a small scale and then figure out in a distributed way, the best way to handle packets. I mean, having a central view really opens up a lot of possibilities. Of course, with the caveat that centralization still has to handle things like scaling and reliability and so on. The other thing that SDN has really brought to the control plane is programmability, right? So, we know the sort of story of the origin of SDN about the difficulty in actually innovating in the network, changing the way the control plane operates by having this tight coupling between the data plane and the control plane, and in fact the management plane as well, all in single devices. SDN actually separates the two, right? So you have control plane applications, things like routing or VPN service, security, whatever it is, implemented in software on a controller, while the data plane still resides on devices. So you still can take advantage of high-speed data plane, and you've got this SDN interface that provides this programmable separation between the data plane and the control plane. And moreover, you've got this set of well-defined APIs. The other important thing that SDN brings to the table is this notion of defining APIs northbound to the application, so these northbound APIs, as well as southbound to the actual set of devices using a multitude of protocols potentially. So many of you may have heard of OpenFlow. It's one sort of exemplary protocol for SDN to devices. And a couple of other things that SDN has brought to the control plane is this notion of how the network is actually represented to applications. So this notion of being able to model the network in a way that's consumable by application. So for example, you might have a model of the network, so this is your distributed network, but you represented it to applications as sort of one big logical switch, for example. To make it really simple to program the network, it's just a matter of plugging in interfaces to ports on one switch. Another model that's common is this sort of multi-tenant model where you have a few different tenants and all you care about is the connectivity between the tenants. You don't actually care about the physical connectivity of the network underneath. The tenants all have basically overlaid paths on top of the network. So SDN has brought this sort of modeling abstraction as well. I'm sorry. And then finally, I think we've also seen advances that SDN has brought in terms of interoperability and open standards. So we have things like the organizations like the ONF, standardizing OpenFlow and related protocols. We have the IETF, of course, that has standardized a bunch of protocols that are related to SDN. And then we have open source projects as well that aren't exactly what you call standards, but they do encourage and sort of enable interoperability between different vendor solutions. So vendor solutions built on the same base, whether it's OpenDaylight, OpenStack, at least there's some chance now that these things will work together. And of course, organizations like Etsy that are also putting out new sets of requirements for providing solutions for things like network function virtualization. But as you, I hope, will agree that if you look at what SDN is today, all these nice control plane features, SDN is still not addressing issues of network management. And that's almost by design, really. I mean, SDN focuses on control over traffic and packets, right? SDN is about implementing routing, forwarding, failover, access control, all these sorts of things that are really about how we manage traffic and packets in the network. And the timescale on which it operates is much more dynamic, right? It's really about choosing paths at the time the flow is set up and worrying about, in real time how protocols converge and so on. So SDN has been focused on this space. Whereas traditional network management, those of you who are involved in network engineering know that network management tends to be very sort of device-centric. It's not really traffic or packet-centric. It's more about devices. So it's configuration of devices using protocols like SNMP or CLIs, or it's monitoring devices with Armon or NetFlow or a multitude of other protocols. And it also typically operates at much longer timescales than you think of the control plane, right? So management operations are definitely out of the current scope of what I would call SDN today. But we also see that there's a bunch of relationships, right, between SDN and interaction with the management plane. So SDN relies, for example, on having a view of the network. So that requires things like device discovery and having an up-to-date view of the topology. It relies on recomputation of paths based on failure notifications. All of those are management plane sort of functions, and hence there's a tight coupling. It's just that the advances that we've made on the control plane side haven't really been observed on the management side. And while there is some management leakage into control plane protocols like OpenFlow, we haven't really seen it done in a systematic way so far. So just before we go further, let's at least identify what we think the elements of network management are. So there's a bunch of things, right? One is what I call sort of the state of the world, right? Network management is responsible for building some view of the state of the world, whether that's topology, statistics about traffic that come through monitoring or other telemetry mechanisms. And then, of course, network management also has a lot to do with how devices behave. So this is primarily around device level configuration. And by device, we don't necessarily mean hardware devices, right? A lot of network function is implemented in software today, and those also have their own configuration interfaces. So by device level config, we're talking about software configuration, hardware configuration, protocol configuration. And then there's also network-wide behavior that has to be configured, right? So, or managed. So this is about network policies that are part of configuration and management, quality of service, the mapping between virtual networks and physical networks. All of that is really part of management plane operation. And then finally, the thing that's not so much about programmability, but also crucial is really the processes and workflows that go into network management, right? So whether this is change management systems, the process by which we introduce new devices into the network, new device qualification, network methods of procedure. So all of these kinds of things are part of the network management plane. And it's hard actually to find things on this list that are addressed by SDN technologies as we see them today. So, the other problem is in network configuration. Even though we've made advances in what we're calling software-driven networking or software-defined networking, is really still stuck we could even say in the dark ages, right? So we still manage our networks using largely scripting against proprietary CLIs. I mean, even large ISPs, including ourselves, are still doing things in a largely traditional and kind of non-SDN, decidedly non-SDN way. We do configuration using these imperative and incremental sort of steps, right? So first we put a device in a certain mode, then we, tell it to set some property, then we set another property, we set a dozen properties, and then that's how we configure sort of in this incremental model, as opposed to being able to define a configuration of how we want a device or a set of devices to behave, tell the device, here's the configuration, and have it make it so, right? This is not the way we configure devices today. We also have a lack of abstractions, right? So if you want to go and configure devices, you typically don't have a common, abstract model of the device that you can configure against. We're talking about everything is very low level. You basically need to understand the CLI in a lot of detail as well as semantics of all those commands to really be able to configure successfully. And then we also have this problem that, lots of times when we're managing our networks, the authoritative state of what is configured in the network doesn't live in some management system, it lives on the device itself. So hence we basically scrape our devices for configuration information. How are you configured? How are you configured? How are you configured? And just keep it in some database and say this is the state of the world. We have to go and scrape from devices every, periodically basically. So this also doesn't make a lot of sense from an SDN point of view, right? In SDN, we have the controller that stores the state of the network. If a device goes away and its flow table, for example, if you have an open flow network goes away, it's the controller's job to repopulate it with the state that it has, the notion that it has of what the paths are, what its state of the network was, as opposed to letting the device figure out for itself or relying on the device to hold what the authoritative state is. So, and then finally, of course, SNMP, which is our our default mechanism for basically doing monitoring and some configuration. But I've yet to meet a network engineer who really likes SNMP or thinks it's really simple as the name implies. So this is our problem, is that we're sort of stuck with these protocols that haven't really evolved to being well integratable into software systems that we want to build to do more automated systematic management of our networks. So the question that we're asking here is really, how can we take these SDN principles that we talked about earlier and really try to apply them to network management? And in particular, I'll focus today more on configuration management because that's the area that we've been looking at in some detail. But there are other parts of network management where this applies as well, including the whole monitoring and telemetry piece. So, I won't get into it in detail, but there's a lot to be done also on how we get data from the network, beyond SNMP. So let's think a little bit, this is maybe a straw man of, what SDN might mean if we try to apply it to the management plane. So if we take the SDN principles, they're on the left-hand side of this slide. Let's start with separation of control and data. We said this was a fundamental principle of SDN. One way that you could think about this in terms of configuration or management is that, separating out where authoritative state of the network lives could be considered the same kind of, or analogous separation, right? So authoritative configuration not managed or not residing on devices, right? So scraped configuration, in my view, should not be considered authoritative, right? You have a separation of what is configured on the device from what is actually authoritative configuration, which lives in a management system. And this notion of centralized control, similarly for configuration, really to have a valid configuration across the entire network requires some coordination and a network-wide view. It cannot be sort of device by device in isolation, right? So it requires this notion of logical centralization. Network abstraction and APIs also apply. So we don't have an ability today, for example, to manage and manipulate these configurations at any sort of abstract or higher level than the lowest command level that's available on the devices. So, if you ever read a router configuration, and unfortunately I've been looking at a lot of them recently, it's impossible to reason about these things. I mean, if you really want to understand at a high level what's going on, you have to spend a ton of time sort of doing all of the variable substitution and following the policy chains and all of this stuff just to figure out at a high level what was the operator trying to achieve. I mean, what is the intent of this configuration? There's no real way to reason about without having some abstract way of thinking about it. And so we don't really have a way to do this today. The same way we have in SDN, where in SDN today we can represent networks as I said, single logical switch. It becomes much simpler to think about, I'm enabling this port, to talk to this VM, and it has these properties, and it becomes much simpler to reason about what's happening. And then finally, for configuration management, we really have very little in the way of standard protocols and interoperability, right? We don't have standard configuration models that we can use to do vendor-neutral configuration. One of the biggest pain points that so many network operators have is that they have very heterogeneous environments, right? So they have, for example, switches and routers from a multitude of vendors. All of them have their own way of doing configuration, especially when you start looking at policy configuration and even simple protocol configuration for protocols that have been around forever. I mean, we have our own terminology that's used on one vendor versus another. Yes, if you've been in the business of network engineering for a long time, you have a rough mapping in your head of what it means to specify something on an iOS XR device and a Junos device. But in general, we don't have a common way of talking to these things. SNMP was supposed to be that way, but if you start looking at the plethora of enterprise, or proprietary MIBs that have been introduced, every device has, a vendor name in front of the MIB name that they support. You quickly sort of deteriorate back to having, very proprietary vendor-specific configuration interfaces. So what would a configuration system look like that was more SDN-like? So again, here's sort of just a straw man. This is all sort of early thinking that I'm interested in your thoughts on. So here's a sort of canonical SDN stack right on the left of this picture. So you have at the bottom southbound protocols, maybe like OpenFlow, that are responsible for talking to different devices in a programmatic fashion. You have this network OS, which is really key. OpenDaylight would be an example of this network OS that supports, multiple southbound protocols. It handles and manages the state of the network from a control plane perspective. And it also exports to applications a set of northbound APIs that are kind of well-defined. And then, of course, you have applications at the top that are taking advantage of these APIs, right? So this is, what we think of when we think of an SDN stack. You can map most SDN controller platforms to this model. So for configuration, what would this mean? So let's try to map these things. So what I think of in terms of application in the configuration world is really the intent, right? Applications are intended to manipulate control state in the network at sort of this abstract level. Similarly, configuration intent, what is it that I want to achieve in the network, can be thought of as sort of the application. So operators are interacting directly with this notion of intent. So they describe an intent that they want to see the network configured to. And then, the API that they use is basically a model of configuration, right? So I have a declarative API that works against a set of models of the network. And these models can be, configuration models as well as other models like topology models. So I have an abstract notion of what the topology of the network is. I have a high-level view of how to configure the network, and I have a declarative API that says, okay, on this network, I want to configure this behavior. Right? So that's what the intent translation to the actual configuration where it starts. Then the equivalent of the network OS is really all the machinery that turns that intent into actual configuration, right? So there's a set of standard models that support that, right? That support these config models and topology models that make up this API. There's a config generation mechanism that has to take what's specified as intent and turn it into actual device level configuration. And there's got to be some kind of authoritative store of that configuration over time in which you can sort of track the evolution of how the network is configured over time. So you can do things like roll back and recover and so on. So it's important that these models be, of course, vendor neutral because we have a heterogeneous network underneath us. But when we generate these configurations, they have to obviously work on different vendor devices. And you'll notice I have this arrow on the right where configuration flow is always going downward. And what we don't want to have happen here is this classic problem where you've configured something in the network and then some operator thinks that they need to tweak something, so they go to the device directly, log in, change something, and now you're completely out of sync with what you think the configuration was, right? So things quickly deteriorate if you allow that sort of behavior. So in this model, the idea is that configuration state only flows in one direction, and that's downward. And if you want to make a change in the network, you have to start back up here. You have to declare what is the intent of the change. Typically, it's tied to some change request, right? And then push that change down the stack so everything remains synchronized. And it's actually hard to change this behavior organizationally. And I can tell you that as we've been embarking on this transformation, it's not easy, of course, to get to this, right? Because there's a lot of legacy sort of thinking and tooling. Operators are used to, or network engineers are used to be able to log into a box anytime they want, and they don't want to give that capability up easily. And then at the bottom, the sort of the equivalent of the southbound protocol in this architecture would be something we could call the configuration pusher, right? So this thing takes the device level config and instantiates it on the set of devices that are needed. And here you can have multiple protocols as well. So netconf is a standard protocol from the IETF that is one way to push configuration. Now they've wrapped netconf in REST interfaces. So you have RESTconf. You have some vendors who provide a JSON RPC-based mechanism to push configuration. So it doesn't really matter at the end of the day what the serialization and the actual transport protocol is. But you need some way of actually pushing the right configuration of the devices using the right protocol for that device. And that's maybe what the southbound protocol driver could be thought of as, right? So multiple transports are possible, and you have obviously configuration across multiple kinds of devices. So I'll just pause here if there's any question or comment. Yeah?
So in your model, everything is run via the operators, but there are times where an application, is there ever a time where you would allow an operator to cede some part of their config model to an application developer? Because that becomes important when you're defining a policy for a particular end device, if they're supposed to get a particular size queue, for instance, because the policy is defined at the application level, where the application needs to ask for configuration to be put down.
Yeah, no, certainly it's not really shown in this picture, but this isn't meant to imply that you only have sort of humans that are the originators of the configuration. So clearly we have lots of automated tools that also are pushing configuration, and some of them will be on behalf of applications. So typically what you would do is define these policies that are available. Let's say they're different QS levels, and then applications can request them. Either an operator actually requests them when setting up the application, or through some automated means when the application is spun up, it requests it, right? So here it's actually very important that the intent, this abstract intent, also be machine readable and writable, not just sort of at the human operator level. But one thing that we've talked a lot about is this notion of operators, when they push a config, it should be like pushing a source code change, right? You push an intent, and it would be great if you had a way that someone else could actually come and review your change, just as you have with source code, right? You push a change, before it gets committed, it has to get reviewed and +1 then by multiple people before it's finally committed, right? So same kind of thing applies here, where you push an intent change, and you could also enable the system to hold that change until it's been reviewed and sort of approved by your peers or whoever, however your process works in your organization. But in addition, you also need the automated thing, right, where you have sort of pre-approved changes or pre-approved mechanisms for pushing configuration changes that can be done automatically. Yeah.
Is there a case where you do the configuration push and then a device says, I can't do that, some kind of an exception? So is there kind of a backward flow through?
Yeah, so there has to be, I didn't talk a lot about it here, but in addition to being declarative, there has to be some notion of transactional semantics here, right? So if I do a configuration push to a bunch of devices, one of them fails, they have to all fail so that I can, and then I have to be notified of it. So yes, there is an upward flow here, but it's mostly notification. It's not, where I configured something down here and then I need to learn about it by scraping devices. So this is what I meant by the downward arrow. But you're absolutely right that, you need both here. And I think that the other thing we're missing in general that I didn't mention about the state of management is we don't have a lot of devices or support for this sort of transactional semantics. I think with netconf, there's been a push to sort of provide that, but I think we're still ways from having it widely supported. Yeah. Any other comments or questions? Okay, let's keep going. So, one way that we want to address this problem is through this notion of, a model-driven approach for configuration. And, in particular, having a set of common configuration data models. And the reason why we think this is so important is that it solves a bunch of problems that we have today in how we do network configuration and management. So first of all, having this ability to do cross-vendor configuration using some base standard model. It may not seem like a big deal, but when you're actually trying to maintain code that talks to a multitude of devices and vendors over multiple revisions, it gets painful quickly, and the level of engineering effort and just the management and operational effort gets big. So having a sort of single model on which I can configure multiple devices is an important aspect of this. Having also this common model, as I said, you can have multiple serialization and transport mechanisms, and this really enables that, right? So you have a common model that's defined. That model can be implemented multiple ways. I mean, you can almost think of it as an API, against which you write a configuration, which then can be validated against that model, right? So similarly, you have an implementation that implements a particular API. There's a set, it's obvious there, whether the implementation really supports the full API and the set of parameters and so on. Here also, you have a common model. You have a bunch of potential implementations of that model, right? So the model can be serialized as JSON. It can be written as XML for netconf. It can be written as a protobuf if you use protobufs as we do. So there's multiple sort of ways to represent the configs depending on what your environment requires, but the model is sort of common. And it also, the model has to enable validation, right? So configurations that are generated in any kind of serialization, for example, need to be able to be validated against this common model. And the model, when I say sort of common vendor neutral models, it's not to say that we don't want to allow vendors to actually extend these models. Yes, I know that you'll immediately think of where we ended up with SNMP, but the idea is that, I think we cannot get away from this notion of extensible base models where a vendor can come in and say, okay, I support the base model, but I've got these additional extensions for my customers who want to use them. I think that's also important to accommodate. So the reaction I usually get when I've talked about this, and including internally, is that this has all been tried before, right? I mean, you point to SNMP and other efforts. Why now? I mean, what's different now? Why do we think this might actually succeed at this point? Well, there's a few reasons, and you can tell me if you disagree. One is that as we progress the control and data planes through SDN, I mean, this lack of programmability, abstraction, centralized views has become even more glaringly absent in the management plane. I mean, the management plane looks more and more in the dark ages as we progress on the other parts of networking through things like SDN. So I think it's really put a lot more attention and focus, on this part of the problem. So operationally, we're still kind of stuck. The other is that our observation has been that network operators, including our partners and ISPs, are really now asking for really a common and automatable approach that they can use in their environments. Right? So every large operator has heterogeneous networks that are very complex to operate, and really to improve the operational or decrease the operational complexity, I should say. There's really now much more of a push for having this. So one of the reasons why I think we've ended up where we are is that we just didn't have a lot of push or pull from the operator side for having this kind of capability. And then finally, I think there's some technology reasons. There's growing traction, I think, now for domain-specific languages for configuration in the industry, both in the standards bodies and also in practice. Things like Yang and netconf, you see a lot more support for these sorts of things and adoption. So we think that the time may be right to actually try to do this again and try to get to where we want to be. Any questions? Okay. So we started an effort at Google that we're now sort of taking to partners externally and hopefully to the broader community very quickly, to develop some of these common configuration models. So as in the process, there's some sort of style guide-like things about what makes a good common configuration model. I mean, there's lots of configuration models out there, but if you really want to have a base model that's widely adoptable and sort of vendor neutral, a few things have to happen. It has to be, of course, standards-based, right? So, for example, if you're providing a model for configuring a protocol, the terminology, the naming, the structure has to be based on how the standard is defined, not how a particular vendor has implemented that standard, right? So that very quickly sort of gets you away from maybe some ways that people are used to configuring networks. So that's something that will have to be considered. the models should be simple and, I put in quotes, limited. So one of the problems I've seen with, configurations that vendors provide is that you can do almost anything you can think of. I mean, there is a knob for every single parameter that you could possibly want to tweak. But, many use cases, I would argue, are not that complicated. And so for those complicated ones, yes, we can have extensions of the model, but base models really ought to be simple, right? They should cover sort of the base use cases that we agree upon as an industry, as a community, and then be limited in that, not trying to expose any and everything under the sun. First of all, different implementations by different vendors don't all support the same set of capabilities, right? Different vendors will have different knobs that they expose for configuration of their devices. So it really doesn't make sense to put those specialized knobs into a base configuration. So it has to be limited in that sense. And then finally, it's really important wherever possible to put in sensible defaults for values and constraints on values, because validation of configuration is also something that's really important. So having a set of overwritable defaults and constraints in the model itself enables this sort of validation. And we can leverage a bunch of existing work here. So we're not trying to reinvent the wheel. We're looking at things like Yang. We think it's actually a really useful language for defining configuration. It's sort of purpose-built. There's lots of configuration languages out there, right? But Yang has been purpose-built for network configuration. We're finding it to be pretty useful for defining these things. And it is an IETF RFC. There are a bunch of, not a bunch, maybe just a handful rather, of base configuration models that have already been published by the NetMod working group in IETF. That's another sort of good source for things like defining base types for internet or network configuration, basic interface configuration. It doesn't have a lot of the more advanced configuration that we need, but at least it gives us some building blocks on which to extend. So rather than redefining what an IP address should look like, we'll take the standards that have been defined and build on those. And then there's other modeling work that's been happening in the IETF. Interestingly, I think there are groups like I2RS, if any of you follow the interface to the routing system working group in IETF, they're also starting to define models, or at least information models, for things like RIBs and policy and so on. And so we can leverage some of that in creating these new common configuration models. And also there's a lot of modeling work that's happened in OpenDaylight that we think we can leverage. So this question always comes up also, how do we support these vendor-specific configurations? I've talked a lot about vendor-neutral and sort of common configuration models, but the question always comes, but I use that particular feature from vendor X in my network, and you're not exposing that to me in the model. How do we deal with that? Well, I think the answer is actually pretty simple. There's a base model, a configuration model. This is just an example configuration tree, right, that users can use to model and configure across any of their devices. And then users can adopt vendor extensions if they want to use some specific feature. And Yang actually has some nice capabilities along these lines. There's the augment models, and you can define augmentations to a model. Basically are nothing more than just ways to graft on additional configuration in particular parts of the configuration tree, right? So the idea here would be that vendors would support this base model directly, and then they can add configuration items that are specific to their products, or as extensions. And just as with open source, I think this model that we have in OpenDaylight and other open source projects is really useful, right? So the open source project, or the open base model, is distributed openly, but that's separate from sort of vendor extensions. So vendor extensions are distributed by vendors that are augmentations to a base model. And so their customers who need those extensions can then get them from the vendor, use them with the base configuration model, right? And we've been doing this for a few different, we've been developing such models for a few different types of scenarios. BGP is one that all large network operators care about, small network operators as well. So basically the model development process, looks something like this for these common models. So for BGP, for example, we defined or identified a few, not a few, it's actually a fairly large set of BGP options that need to be configured based on a few different operator use cases, right? And these operator use cases are being developed by us and also other operators that we're working with. Then the hard part is actually to look across the set of implementations of BGP, for example, to determine, how many of the implementations actually support a particular configuration feature. I mean, having a base model shouldn't mean that you basically give up all of the features that you're used to. But on the other hand, putting in everything that only one vendor supports doesn't really make for a good base or common model, right? So it does take some work to actually look across the board and see what is supported as a standard configuration item. Then defining an overall model structure. Something like BGP is interesting, right? Because if you're familiar with how BGP configuration works, you can configure it at multiple levels. So it's sort of organized in a hierarchy, right? You have groups, and you have specific peers within those groups, and you have address families within those peers, and all of those things have different configurations. So the structure of the model becomes really important. And moreover, it's important to define a structure that is actually close enough or implementable by most of the vendors that are going to be supporting that model, right? If you define a structure that's completely different than how most vendors have implemented that configuration, it's going to be very unlikely that you'll get it supported by those vendors. So to do that, basically we've looked across, major and smaller vendor implementations. We've looked at open source implementations in the case of BGP and tried to come up with a set of common configuration items that we think are, widely implemented and also structured in the way that we've done in the model. And then it's a question of how do you modularize the model. Having the models be defined in sort of small chunks is really useful, right, as multiple modules so that you can separate out sets of functionality. In the case of BGP, it was fairly straightforward to think about it as sort of the protocol configuration, and then BGP is really not useful without policy, so there's a whole policy configuration as well. And these two things together make up sort of the common model for BGP. And then you want to do similar things for other types of protocols and services. So then, transcribing these models into Yang modules, right? So this was sort of the next step. And then finally validating the models. We use this great tool that you may have heard of called Yang. It's basically a Python tool that lets you validate and generate multiple kinds of serializations from Yang models. It's available as open source. And then, publishing these models for comment is sort of the last step here. So I'll just lay out kind of the roadmap of what we're trying to do. So as I said, we're working on an initial set of these vendor-neutral configuration models, and we've started to engage some other large operators, to enhance and basically add to this initial set of configurations. So, looking at things like BGP and VPN and MPLS and other sorts of services. And as you can see, this is sort of service provider-centric because that just happens to be our perspective, but obviously this applies to other types of configuration in other environments as well. And we've adopted Yang as a configuration language, as I mentioned. So the next step is really to publish these models and code for the models, as in the Yang code itself, jointly from this set of users. So we're trying to take a very user-driven approach here, and then as a next step, sort of start to engage with vendors to actually provide additional feedback for these models, right? So we want to invite participation for enhancements from other network users as well as vendors. And then, of course, the last step and the most important one is to work with the same vendors in the community to actually support these models in a variety of their platforms. Because without that, we really haven't succeeded. I mean, the idea is to really simplify how we do configuration across these heterogeneous environments that all of these operators have. There's other things that we're also working on along these lines. So these open configuration models are one part of the effort. There's another effort on actually creating an open schema or model for network topology as well. I think we've observed that there's really a need for having a standardized, unified multi-layer topology model. And what I mean by that is something that actually provides a way for controllers, tools, and even different administrative domains to exchange information about topology. I think we can enable a lot of interesting use cases if, you and I in different ISPs, for example, can exchange summary views of topology. Talking the same language, gives us a lot of capability of how we can actually think about routing traffic, handling, failures, congestion, etc. So we're lacking this sort of, model and language to exchange this information. And so there are topology models out there, but in my observation, they tend to be very kind of specific to a given layer. So, layer 3 model, a layer 2 model. So for example, in OpenDaylight, we have, of course, topology model that's in the controller, but it doesn't certainly span, all of the layers of the network that you might care about. So this includes things like physical devices, even buildings and conduits, and sort of really part of where things are located that could be important for some applications, up to physical layer like ports and devices, line cards and chassis, then optical transport links, then network layer links, and so on. So including logical and virtual, right? All part of the same topology model. So we've actually made some progress on this internally. We have a hierarchical multi-layer model that we've developed that is encoded using protobufs. And we're actually exploring ways on how we can bring this model out to the community, both the schema and the tooling, right? It's not really useful, the schema alone. There has to be tooling that enables people to write applications that can ingest these models, parse them, traverse them to answer interesting questions. So this is another part I haven't talked as much about because we're not as far along here, but it's something that we're also looking at sort of bringing out to the community as a useful tool to getting to this vision of an abstracted network, both from a configuration standpoint and topology. And then, we're at the OpenDaylight mini summit, so I haven't said a lot about OpenDaylight yet, but clearly we think there's a role for communities like OpenDaylight. And I have been in the OpenDaylight community for a long time, so I really would like to see a lot more engagement. So one thing is, I think there was a question in the panel about, what is OpenDaylight doing in the space of management, and we're hoping that this work will actually encourage a lot more attention and hopefully projects even to be spun up that are much more oriented towards SDN-based management as opposed to just control a new function feature. And I would like to also point out that there's a ton of Yang experts in the OpenDaylight community that we want to be able to leverage in this effort, right? So we like to leverage all the expertise and experience in the OpenDaylight community, along with the other communities like an IETF, NetMod working group, to help push these configuration models. And then finally, work with the community to eventually take these models, improve them, extend them, and get them supported. I mean, OpenDaylight has a large set of major and smaller vendors that are really important to get their support for these models. I think OpenDaylight is a good forum for us to pursue some of that. And then finally, I'll just end with this. I mean, software-defined networks really require also software-defined operation. It's not just enough to have software-defined control and data planes. We really need the operational side as well. And we really want to transform the management plane as well. I think Google is just as guilty of kind of paying more attention to control and data than we have to management, and now we're really trying to see how we can similarly transform the management plane. And we'd like to do this with help of the broader community. So that's all I had. Thank you very much. If there are any questions or comments, I'd be happy to, yeah.
Will Google be OpenDaylight members?
I don't know, is my honest answer. I mean, we're certainly observing OpenDaylight, and when I was not in Google, we certainly talked to Google about joining. I think there's some new user forums and so on being set up for OpenDaylight, where the idea is to get not just Google but other users of the network and operators as well. I mean, similar to what kind of ONF has done. I mean, that might be a good way to engage. But I can't really say. I don't really know, actually. It's not up to me, actually, to join. But we are definitely staying engaged, as you can see. I mean, we still monitor what's happening. We're very interested in seeing the project succeed and actually, advance and start to get into other use cases that we could also, benefit from and contribute to. Yeah.
You talk about developing new config management tools, Yang, for example. Don't these tools already exist? Puppet, Chef, and all those, can you not leverage them?
Well, I think that this, so someone else has also asked me that question that, this person actually didn't like Yang as a model, so they said, why don't you just define a nicer language and then use something like Puppet or Chef to do management of the same as servers. I mean, certainly you could take that direction. I think the advantage of Yang is that, first of all, it is a common standard model. There is a fair bit of support already among network vendors. So, we've talked to some of the largest vendors. They all have programs in place, if not already published models to develop, Yang representations of their config. And, Yang is a sort of purpose-built config language for network configuration. So I think you know, all those things taken together led us down this path of looking at Yang. Now, you said there's a lot of existing stuff. The issue here is really the language exists, and they're actually coming out with a new version of Yang. So the problem is, though, the models don't exist, right? So having the language to describe the model is one thing. Having standard models is where the gap is. And I think that's what this effort is really focused on. So we're not trying to reinvent the language, we're trying to use what's there. But I think what we see that's lacking and the big gap is really having the standard models that we can use. Any other questions? Yeah?
The data model, do you have any opinion about SID or other data model that is known for the management plan?
SID, did you say?
SID, S-I-D.
I'm not familiar with SID, I'm sorry.
It's for
It's a TM form.
TMM, yes.
Okay, okay. I mean, we have looked at, you know, DMPF and those kinds of models in the past. You know, I think, again, it's really a question of what seems to have some traction and is suitable, right? So, you know, we see a lot of activity happening in building Yang models. I think many of the IETF working groups now, for example, are actually trying to build Yang models for their respective areas. So as opposed to concentrating all that activity in NetMod, that's happening. So we want to basically take advantage of that momentum. And so that's what led us down this path. I mean, if you think that there's really another language that we should consider for this, I mean, we should talk. Yeah.
So I'm one of the authors of the topology data model that's there in OpenDaylight as well as IETF. What do you think pitfalls or what is missing in those models? I observed you said the layering is missing. We were actually developed layering in mind. So this is kind of isn't this kind of a shallow effort that's being done?
It could be. I mean, to be honest, we haven't actually done a full survey of really what's available. So I think one of the first things that we're doing in this space, I mean, we've observed that there's a need for this. What I think we haven't fully convinced ourselves even is that there's not already something that might address the same issues. You know, we really like the model that we have, and we think it's mostly because of it's fairly complete in the set of layers that it already supports today, and it's also fairly simple, and it has a bunch of tooling around it. So I think that's why we thought it might be a useful thing to pursue. But I think to your point, I think we definitely need to look at what else is out there.
Because it's available in OpenDaylight, and OpenDaylight has toolings to convert YAML to classes and other things. So
So this is not about Yang, right? So this is a different kind of model. We're not talking about configuration models with Yang, and we don't actually think Yang is the right way to describe topology, but you know, we can talk about that offline. Any other? Okay, thank you very much.